We're taking a look at the first couple of sections in Module 4, and from Module 4.1, we're taking a look at perimeter and circumference. And then in the second module, 4.2, we're taking a look at area. Now, we're taking a look at the basic geometric formula or basic geometric shapes of a square, a rectangle, a triangle, a circle. You will also encounter some shapes such as a trapezoid and like a parallelogram. Okay, but we'll talk about those things as we get to them. So when you're talking about perimeter, perimeter measures the distance around an object. So for an example in a square is a four-sided quadrilateral in which all four sides have the same length. So in order to find a perimeter, we simply multiply all four of the side lengths, 4 times s, and that will give us the length. We can also find the circumference of, the perimeter of a rectangle. For a rectangle, the opposite sides are parallel and congruent. So in order to find the perimeter of a rectangle, you will simply add your 4 sides, right? We have 2 sides that are considered to be the width, 2 sides that are considered to be the length. So we're given a formula that the perimeter of a rectangle is twice the length plus twice the width, right? Basically the same thing as adding all 4 sides. You could also find the perimeter for a triangle, right? You would simply add the 3 side lengths. For a circle, we don't call it the perimeter, we call it the circumference. The circumference measures the distance around the circle. And it's given by the formula 2 times pi times r. So C is equal to 2 times pi times r. There's another formula for the circumference. The circumference can equal to pi times d. D is going to be the diameter. So the radius, it goes from the center to the outer rim of a circle. The diameter goes from one edge of the circle through the center to the other rim of the circle. This is the diameter, which we're going to call D. So you have to be careful. In some of the problems, they give you the diameter. In other problems, they give you the radius. Now we'll take a look at these area formulas in the next section. All right, so let's take a look at some problems that are dealing with perimeter. So in these particular problems, we're not looking at basic shapes. Here we're looking at this not so basic shape, and we're asked to find the perimeter, right? We're asked to find the distance around this figure. So as I take a look, I'm going to look at this far side first. This is a total of 16 meters, right? So this side length will be 16. This side length is 7 meters. I'm missing this vertical length. I'm also missing this horizontal length. I'm missing these 2 side lengths, but I'm giving the rest of my sides 10 meters, 20 meters. So how can I figure out the 2 missing sides? Well, in order to figure out the 2 missing sides, I'm going to treat this as a rectangle, right? So what I mean by initially looking at this as a rectangle. In a rectangle, the opposite sides are parallel and congruent. So that means if this horizontal base is 20 meters, that means that for the top of my figure, it should also measure 20 meters. So I'm going to do a little subtraction. So if this is 7 meters, this has to be equal to how many meters in order to total 20 meters? Well, 7 plus 13 is 20. So if this side is 7 meters, the other horizontal side length would be 13 meters. So altogether, that gives me a total of 20 meters. I'm going to do the same thing for my vertical side. Notice that for this rectangle, if this side length is 16, from here to here should also be 16. All right, so I'm looking at my vertical length. So that means that if this side is 10 meters, then this other vertical piece would have to equal to what to give us 16 meters? 6. So now we have all of our side lengths. So now I'm going to simply add them up all together. So the perimeter is equal to 7 meters plus 6 meters plus 13 plus 10 plus 20 plus 16. Right, so we should have a perimeter of 72 meters. All right, so that was for the first example. So here we should have 72. All right, let's take a look at the next example. And here again, this is not a classical geometric shape. Right, if we take a look at it, it's actually a half circle. And then we have 2 vertical sides, and then we have that horizontal base. So in order to find the perimeter, we have to know all of our side lengths, right? So if this side is 5, that would automatically make that opposite side 5. But in order to find the circumference for the half circle dome, we're going to use a formula. If we go back to the formulas from the beginning, notice that the formula for a circle is equal to 2 times pi times r. If you're dealing with a half circle or a semicircle, right, we're simply going to take the formula for the circumference, which is C is equal to 2 times pi times r, and we're basically going to split it in half. So if we split it in half, the 2's are going to cancel. So the circumference of a semicircle is pi times the radius. So we're going to go back to our figure, and I'm going to calculate the circumference for the semicircle. So the semicircle is equal to pi times r. I'm going to substitute pi for 3.14. I'm going to substitute r for So keep in mind for R, the radius is the distance from the center to the outer rim of your circle. So if I look at my bottom horizontal base, if the diameter, which goes from one end to the other end, is 5, the radius is going to be half that distance. So the radius that we're going to use should equal to 2.5. So we're going to multiply 3.14 times 2.5. times 2.5, and we have a circumference of 7.85. So now I'm going to add all my lengths. So we have the cylindrical half dome, which is 7.85. Plus we have our 3 side lengths of 5 feet. So 7.85 plus 5 plus 5 plus 5. That gives us 22.85. And when we round to 1 decimal place, we get 22.9. Now, one thing about the unit, if you're dealing with perimeter or circumference, the unit is in the unit alone. So what I mean by that is the unit of measurement here is feet. So our unit of measurement should be in only feet. All right, and here is the last one from this section. It's sort of a word problem. And it's the circumference of a coin. And it says the $1 coin depicts Saskatchewan and her infant son. The diameter of the coin is 26.5 millimeters. What is the circumference? Use 3.14 for pi. Now, since they give us the diameter, I'm going to use a formula. The circumference is equal to the pi times the diameter. So I'm going to substitute pi is 3.14. I'm going to substitute the diameter for 26.5. So this is 3.14 times 26.5. And we have a circumference of 83.21 millimeters. All right, so circumference and perimeter are in the unit alone. So here's what I mean when I say by the unit alone. It's measured in the unit raised to the first power. Now, when we talk about area, and I've also included some area formulas, area is given by square units. And later when we talk about volume, volume is given by cubic units. Right? So perimeter measures the distance around an object. So just to go back to the top, for our formulas, perimeter and circumference. measure the distance around an object area measures the amount of surface an object has. And the area is measured in square units, right? For example, the area of a square is simply a side squared. The formula for the area of a triangle is 1/2 the base times the height. The formula for the area of a circle is pi times the radius square. The formula for the area of a rectangle is simply the base times the height. This is the area for a rectangle and the parallelogram. Right. We have the area of an ellipse, which we don't quite use in this class. And then last we have the area of a trapezoid. The area of a trapezoid is 1/2 the area of the base and this formula is written a little bit different. All right. So here's the formula we're going to use for a trapezoid. Okay, so in a trapezoid, we have two sides that are parallel, and then we have two opposite sides. The two parallel sides are what are called the bases. The little b is called the little base, and then I have big B, which is the big base. And then you have your height. So in order to find the area of a trapezoid, it should equal to 1/2 the little base plus the big base times the height. So what this formula over here is actually missing is a B. All right. So it's 1/2 the little base plus the big base times the height. All right, let's take a look at some examples. So now here's the first example that you see, and this is actually a parallelogram. Right. And the area for a parallelogram is simply the base times the height. So I'm going to substitute the base for 8 feet, the height for 7 feet. So we should have 56 feet squared. So here's where the square units come in whenever you deal with area. From algebra, there's something called the exponent rule, and it says that a to the m times a to the n is a to the m plus n. So when you multiply like bases, you add your exponents. So if I'm looking at like feet times feet, this feet is understood to be raised to the first power. This other foot is understood to be raised to the first power. So when we multiply like bases, we add our exponents. So this is what gives us square feet. Now on the problems, the unit is given, but this is the reason why. All right, so for that first problem, we have 56 square feet. Going to the next example, here we're dealing with a word problem. And it says comparing areas. It says the area of a square, the side of a square is 10 yards long. So I'm going to just jot out a square. So remember, in a square, all sides are the same length. Then it says if all four sides are increased by 6 yards, I'm going to draw another triangle. So 10 plus 6 is 16. So I've increased my side by 6 yards. It says by how much is the area increased? And then we're asked to answer this question in 3 parts. It says the area increases from blank square yards to blank square yards, which is an increase of blank square yards. So for this first blank, I have to figure out the area for a square that has a side of 10 yards. So the formula says that the area of a square is, we simply take a side and square it. So I'm going to substitute S for 10. So 10 squared is 100. So 100 square yards is the area for my first square. Next, I want to find the area for my second square. So again, the area is equal to a side squared. In this case, we're going to substitute a side for 16 yards. So 16 squared is 256 square yards. I'll take it off. One second. Make sure 051. I was not aware that it had. Okay, refresh it and it should be gone. Okay. It's gone? Okay. All right, so the last part of the problem, so this is 256 square yards, and it says which is an increase of blank square yards. So I'm simply going to take 256 square yards. I'm going to subtract 100 square yards. So that gives us an increase of 156 square yards. All right, so that was in the form of a word problem. And also the last one, it's an application problem, and it deals with a painting. And it says the painting below is from the Getty Museum. We're asked to find the diameter, the circumference, and then find the area of the circle that is inside of the square. So now if we notice, what we're actually taking a look at is this square, right? That's on the outer rim of this circular person on a horse. And it says that this length is 17 7/8 inches. So it's giving us the side length of that square. We're asked to find the diameter of the circle within. So now if you take a look closer, the 17 7/8 inch, that is actually the diameter, right? Because if from here to here is 17 7/8 inch, if I were to draw a line in my painting, I'm going to change the color. Let's say from here to here. That would also measure 17 7/8 of an inch. So this, in essence, is the diameter. Okay, so let me just clear this up. All right, so this is the diameter. 17 7/8 of an inch. I'm going to change it to a decimal. So since 17 is my whole number for my fraction, it's also going to be the whole number for my decimal. If I were to decimalize 7/8 in the calculator, I get 0.875. So 17.875, that is the diameter. We're also asked to find the circumference. So remember, for the circumference, we had two formulas. The circumference is equal to 2 times pi times r. Or if you're given the diameter, the circumference can equal to pi times d. So since we have the diameter, we're going to use the pi times d formula. So we're going to substitute pi for 3.14. We're going to substitute the diameter for 17.875. So if we put that into the calculator, 3.14 times 17.875, we have 56.1275. And then for the last part, it says the area. So remember that the area for a circle is pi times the radius square. So we're going to substitute pi for 3.14. The radius, remember that the radius is equal to half of the diameter. So in order for me to find the radius, I have to take the 17.875 and I have to cut it in half, right? There is no alternative formula for the area, right? There is an alternative formula for the circumference, right, if you're given a diameter. But if you're trying to find the area, you must use the radius. So I'm going to put in 17.875, and we're going to divide that by 2. So the radius is 8.9375. $8.9375. So writing this all out, we have 3.14 times 8.9375 squared. And if we put that all in the calculator, 3.14 times 8.9375 squared, we have 250.82, and since we're talking about area, square inches.